Hi students, welcome to ACE online platform. Here we are going to deal with the SSC JE exam, which is targeted for electrical engineering students for 2024. Okay, fine. So especially I'll going to deal with the electromagnetic fields. Electromagnetic fields or electromagnetic theory, SSC JE electrical 2024 electromagnetic fields or EMF or electromagnetic theory. Most of the students do not pay much attention to this subject. Of course, this subject is small for the electrical engineering students. Let us focus on the syllabus. This is the syllabus. Electrostatics, magnetostatics and time varying fields. So, the three topics, electrostatics, magnetostatics and time varying fields, is a small subject, but very good weightage. If you observe the previous papers, minimum 4 to maximum 5 questions are asked from this one. Very fundamental questions, theoretical questions, numerical questions, straightforward questions where you can easily score the marks if you remember the formulas. Okay guys, so what I will do, so I have seen all your previous papers, not only SSC JE, other things also, RRB JE, SSC JE, state service exams. Especially our interest is only for SSC JE. If you do some survey of the previous papers, you can notice some topics are very important, repeatedly asked. So we're going to spend the time on those topics. Fine. So there is no much questions in the time varying fields. There is only what is called a Faraday's law. Okay. So from the electrostatics and magnetostatics, we're going to deal with some of the topics. We'll do some revision kind of things and we're going to see the questions associated with them. Okay guys, fine. So let me turn the page here. Electric field due to infinite uniform line charge. Okay, see here, let us deal with this one. So this topic is related to the electrostatics. Here the line charge is represented with the rho L. Units are coulomb per meter. Charge per unit length is called line charge. Okay guys, so now let us say I have got some infinite line charge which is extending from minus infinity to plus infinity. Okay guys, so what is the charge on this one? The charge on this one is rho L. Units are coulomb per meter. Now I want to find out what is the electric field at a certain distance. At a perpendicular distance, at a distance of rho. So this is a distance rho. I want to find out the electric field here at a distance of rho. So this is a perpendicular distance. Remember, this is not a perpendicular. This is not a perpendicular distance. Okay. So the electric field here, suppose if it is a positively charged one, it is radially outwards. Fine. So the electric field is like this. So this is E rho, radially outwards. Fine. So we will not go into the derivation part. What is more important for our exam is the formula. So what is the formula here? Electric field due to infinite uniform line charge is E is equal to vector, you can write in the vector form. E is equal to rho L divided by 2 pi epsilon rho into rho cap. So this is the formula. Okay guys, and what are the units for the electric field? It is volt per meter. If nothing is mentioned, you have to take epsilon is equal to epsilon naught. In general, epsilon is equal to epsilon naught epsilon r. This is absolute permittivity, epsilon r is a relative permittivity. If nothing is mentioned, you can take epsilon r is 1. And what is this rho here? This rho is a perpendicular distance. What is this rho? This is a radial direction. What it is? Electric field is in the radial direction. Okay. So this is the electric field formula due to infinite uniform line charge. I will repeat again. So E is equal to, you can write even in the scalar form also, this unit vector is representing the magnitude. So in our most of our papers, there was a questions only on the scalar field, scalar quantity. It is rho L divided by 2 pi epsilon into rho. Okay, you can just remove this one. Suppose if it is the positively charged one, electric field is radially outwards. If it is the negatively charged one, electric field is radially inwards. Okay guys, fine. Let me turn the page here. So this is the one formula, very much important, very important. Number of times questions was seen on this. There is a one more formula, electric field due to infinite uniform sheet charge. Okay, see here, the electric field due to infinite uniform sheet charge. What is the charge on this? It is rho s coulomb per meter square. It is a surface charge. It is a sheet charge. If it is a sheet charge, what is the charge on this sheet? It is rho s coulomb per meter square. I want to find out what is the electric field at certain distance. So you should say what is called normally outwards. You should not say radially outwards, because this is a sheet. Sheet will have only two sides. Let me show you. So in the previous case, we have seen what is called a line charge. Suppose if it is a line charge, so the electric field is outwards from all the sides. Now it is a sheet charge. Sheet charge is something like this. It is a sheet charge. Sheet will have only two sides, this side and that side. So the correct word is normally outwards. What you should say? You should say normally outwards. You should not say radially outwards. Terminology is very important. Okay guys. So what is the electric field here? E is equal to, the formula, the direct formula is rho s divided by 2 epsilon into plus or minus n cap. Quite interesting. Electric field due to infinite uniform sheet charge is not dependent on the distance. It is independent of the distance, and that too it is in the normal direction. So here it is independent of distance. Independent of distance. And this is in which direction? This is in the normal direction. Okay guys, yes. So terminology is very important when it comes to the, I'll repeat again, when it comes to the line charge, you should say radial direction, radially outwards for the positive charge, for the negative charge radially inwards, and it is a perpendicular distance. So here when it comes to the infinite sheet charge, it is independent of distance, and it is in the normal direction. For the positive charge normally outwards, for the negative charge normally inside. Okay. Suppose if you take this side as a positive normal, other side will be negative normal. Okay guys, extremely important formulas these are. Now let us take some questions associated with them so that you will understand what is the standard of questions asked, what kind of questions asked. Fine. So here is a question. Directly theory kind of questions, you can see the electric field due to thin infinitely long straight wire of uniform charge density lambda. Here in this question, charge density is lambda, is given as dash, where r is a perpendicular distance, you can see, okay, of the point from the wire. So epsilon naught is a permittivity of the free space. So what is the formula? The formula here is E is equal to, just as magnitude is enough, rho L divided by 2 pi epsilon naught. Nothing is mentioned. You are taking epsilon is equal to epsilon naught. But here epsilon naught into rho. Rho is a perpendicular distance. So what is the line charge here? Lambda divided by 2 pi epsilon naught into what is the perpendicular distance? Perpendicular distance is r. So lambda by 2 pi epsilon naught into r. Lambda by 2 pi epsilon naught into r. Option A is the answer. This question is directly based on identifying the formula. Next question. A little bit you have to think about this one. Okay. Now observe here carefully. Two infinitely long parallel conducting plates having the surface charge density sigma and minus sigma respectively are separated by a small distance between them. The plates is in vacuum, then the electric field in the region between the plates is. So there are two plates here, just you need to think about this one. There are two infinite sheets. So there is a one plate here. What is the charge on this one? Coulomb per meter square. Okay. What is the minus sigma Coulomb per meter square? Suppose it is a charged, it is an infinite sheet charge. So the electric field is normally outwards. So this white color is due to this one. Okay, fine. So I'll use yellow color for this. So this is a negatively charged one. So the electric field lines is inside, 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 inside. So what is happening? Electric field due to this one will going to add up in between. Will going to add up. Okay. So what is the electric? We have to just add the things here. So what is the total electric field between these two regions? Which is formula. What is the formula? Electric field E is equal to rho s by 2 epsilon naught. So you have to add due to this one and this one. Sigma divided by 2 epsilon naught plus sigma divided by 2 epsilon naught. Okay guys, which is equal to sigma by epsilon naught. Okay. So if it is a positive, negative, so electric field between these two things will going to add up. Suppose if it is a positive, positive will cancel out, will become 0. Negative, negative also will cancel out. So what is the answer? Sigma by epsilon. Sigma by epsilon naught. Option C is the answer. Okay guys, next question. The electric field near a conducting surface having a uniform charge density of sigma is given by. So what is directly it is the formula based question. Sigma by 2 pi epsilon is normal to the surface. So small correction here, it is 2. Sigma by 2 epsilon, it is a normal direction. Each and every word is very important. Sigma by 2 epsilon naught, normal to the surface. Option D. So it is a normal direction. Okay. It is not parallel. So if the sheet is like this, the sheet is like this, electric field is normal direction, not parallel. Okay, next one more question. Infinite uniform line charge of 10 nanocoulomb per meter is given. Find the electric field at a perpendicular distance of 1 meter in the air. Okay, so line charge is given. What is the electric field E? What is the formula? E is equal to rho L divided by 2 pi epsilon naught into rho. So what is the charge here? 10 nano. 10 into 10 to the power of minus 9 divided by 2 pi into 1 by 36 pi into 10 to the power of 9 into perpendicular distance. How much is this? 1 meter. Okay, so this will become 180. You can check out 180 volt per meter. Okay, guys. So what is the answer here? Option C is the answer. 180 volt per meter. Yes. Next question. Direct formula based question, identifying formula, theory questions, isn't it? So these are the models of questions you can see in the previous papers. Next question, by guys. Infinite uniform sheet charge of 1 by 9 pi nanocoulomb per meter square is given. Find the electric field at 10 meters away from the sheet in the air. Okay. So is asking what is the electric field due to infinite sheet. So what is the formula? Electric field due to infinite sheet is E is equal to rho s by 2 epsilon naught. What is this rho s? It is 1 by 9 pi into 10 to the power of minus 9 divided by 2 divided into 36 pi into 10 to the power of 9. Okay. So here it is 18, you can check out it is 2 volt per meter. Such a direct questions you can see in your previous papers. So 2 volt per meter, option B is the answer. Okay. So these are the wide varieties of questions which are seen on the two formulas, extremely important formulas. Electric field due to infinite uniform line charge, the other one is electric field due to infinite uniform sheet charge. So these are the topics which are related to the electrostatics. Now let us focus on some of the topics which are related to the magnetostatics. Direct formula based. Current element. I want to find out what is the magnetic field due to the current element. Yes. So the current is flowing like this. Okay. I want to find out what is the magnetic field at certain distance, at a perpendicular distance of rho. From your basic physics, you know that if the current is flowing like this is the direction of magnetic field. Okay. So this is the direction of magnetic field. So if you consider in this plane, magnetic field will go inside. I will take in the angle direction. Suppose if the current is flowing like this, magnetic field will be like this. Okay. So from here, you have to remember, I will going to see the corners. This corner and this corner. This corner and this corner. What is this angle? It is alpha 1. This angle is alpha 2. So how angles are defined? Always remember, it is something like a crocodile mouth. So this is how the angles are defined, something like a crocodile mouth. From here you need to see the corner, this angle and this angle. This angle is alpha 1, this angle is alpha 2. Okay. So the formula here is B vector is equal to mu into I divided by 4 pi rho into sin alpha 1 plus sin alpha 2. How angles are defined? That is very important. Into phi cap, angle direction. Okay. You can write this one in the scalar form also. B is equal to mu I by 4 pi rho into sin alpha 1 plus sin alpha 2. Okay. Even you can write the H vector. H is B is equal to mu into H. So what is the H? H is equal to I by 4 pi rho into sin alpha 1 plus sin alpha 2. Okay guys. So what are the units for this one? It is Weber per meter square. It is ampere per meter. Most of in our discussions in exam you will going to get the question on this H vector. Just it is a matter of mu. Okay guys. Fine. So that is a B and a H. I will going to turn the page. Let us modify this one for the infinite conductor. This is a finite conductor. I have shown the boundaries. Suppose if it is extending from minus infinity to plus infinity, what happens? Then that is called infinite line. So how you can modify that formula to the infinite line? I can show with the arrow like this. Magnetic field direction remains same. If the current is flowing like this, so my fingers will going to show the direction of magnetic field. So the magnetic field here is inside, it is B phi. Standing here, I want to see the corners. So can I see the corners? No. So what happens to the angles here? Like this, and like this. Like this, and like this. So what happens to the angles? Can I see the corners here? So this is 90 degrees, this is also 90 degrees. So alpha 1 is equal to alpha 2 is equal to pi by 2. So this is the modification you need to do for the previous formula. So here B is equal to mu into I divided by 4 pi rho into sin alpha 1, it is 90 degrees is 1 plus 1. So what is this B? B is equal to mu into I divided by 2 pi rho. This is a B. And what is the H? H is equal to I by 2 pi rho. What are the units here? Weber per meter square. It is ampere per meter. Okay guys, so we can have some varieties of questions on this one. So it is a finite length conductor, infinite length conductor. Now observe here, here is a question. A square loop of side D carries a current I amperes. The magnitude of magnetic field intensity at its center is. Okay, see here, let me show you. So there is a square loop here. There is a square loop here. It is carrying the current in the clockwise direction. Carrying the current, he has not said whether it is a clockwise or anti-clockwise. So the current is flowing like this. How much current? I amperes. Okay, is asking what is the magnetic field at the center. So what happens due to all these currents? You can put your thumb like this. Your fingers will going to show the direction of magnetic field. So here is a magnetic field direction like this. Here is a magnetic field direction like this. So what is happening? Magnetic field here, due to all the sections will going to act inside. So it will going to add up here. So magnetic field here is due to this one, 4 sections. So instead of taking 4 sections, I will take only due to single section and I will going to multiply with the number 4. Okay guys, and what is the side here? Side here is a D meters. And this is a D meters. Okay, let me take this one square one more time. Okay, how much current is flowing? I. So from sitting here, I will going to see the corners. This one, this corner and this corner. And what is the distance from here to here? It is a D by 2. What is this angle? It is pi by 4. What is this angle? It is pi by 4. Okay guys, and what is the distance from here to here? It is D by 2. Okay guys, fine. So let me turn the page here. So what is the magnetic field due to each side? You can use the formula what I have given. It is I by 4 pi rho into sin alpha 1 plus sin alpha 2. So magnetic field due to each side is equal to I by 4 pi rho. What is the perpendicular distance? It is D by 2. Into sin alpha 1. What is how much is the angle? It is sin 45 plus sin 45. It is 1 by root 2 plus 1 by root 2. So Hs is equal to I by 2 pi d into 2 by root 2, which is I divided by root 2 pi d. So this is a magnetic field due to each side. What is the overall magnetic field? H total, which is equal to 4 into Hs. So which is 4 into I divided by root 2 pi d. So H total is equal to 2 root 2 I divided by pi d. Units are ampere per meter. So that is the answer. Okay, 2 root 2 I by pi d. I will give one shortcut for this. You no need to do all these things section by section. So there is a shortcut here. What is the shortcut here? You can read out. For n equal sided polygon, with a side D and carrying the current I, the magnitude of magnetic field intensity at its center is given by n into I by pi d. N into I by pi d sin 180 by n tan 180 by n. So this is a formula. Let us take some examples on this formula. What is a square? It is a 4 equal sided polygon. So if I take n is equal to 3, that means if the current is flowing in a equilateral triangle kind of thing, then what happens to the magnetic field at the center? Fine. So how much is the current flowing here? Here it is like this. So here it is I amperes. So what is the magnetic field at the center here? H is equal to 3I by pi d. 3I by pi d sine 180 by n. It is sine 60, tan 60. So H is equal to 3I by pi d root 3 by 2. This is root 3. So H is equal to 9I by 2 pi d is the answer. Units are ampere per meter. Let us take one more example. N is equal to 4. If n is equal to 4, we have already seen. But I want to get this one with the help of the formula, shortcut formula. Okay. So what is the shortcut formula? H is equal to 4I by pi d sine 180 by n. Okay. So sine 180 by n into tan 180 by n. So 180 by n. So 180 by 4, it is sine 45 into tan 45. So H is equal to 4I by pi d. It is 1 by root 2 into 1. Okay guys. So H is equal to 2 root 2 I by pi d. Array, we got a same thing. Let me go back. 2 root 2 I by pi d. You can check out here. So don't go in a conventional manner. It is a time taking. Instead of that, you can use that ready-made formula, shortcut. Okay. So here is the thing. 2 root 2 I by pi d. This is how you can directly get. Let us have one more example. If n is equal to 6, what is the conventional approach? You need to take each section and you have to find out the magnetic field due to that section, and later you need to multiply with the number 6. So instead of doing that, you can use that shortcut. What is the shortcut? H is equal to 6I by pi d sine 180 by n. Okay. 180 by 6, it is a sine 30 degrees into tan 30 degrees. Okay guys. So what happens to this value? H is equal to 6I by pi d. It is a 1 by 2 into 1. Am I correct? 1 by root 3. So it is 3. It is root 3 I by pi d is the answer. Units are ampere per meter. Okay friends. So let us have one question here. This is one of your previous question. Magnetizing force at the center of the square, each of arm 2A. So the side is 2A. Length shown in the below figure is. So it is carrying the current I amperes having the side 2A. So what is the magnetic field at the center? H is equal to formula Ni by pi d sine 180 by n tan 180 by n. Okay guys. So how many sides? It is 4I by pi d. What is the d? It is 2A. Sine 45 degrees tan 45 degrees. It is 2I by pi a. So it is 1 by root 2 into 1. So which is root 2 I by pi a. Units are ampere per meter. Root 2 I by pi a. Option A is the answer. Okay guys. Here is a one more question. It is based on the infinite line current. See here, all these are for the finite lengths. So I have given some two formulas. This is a magnetic field due to the finite length current carrying conductor. Okay. And if you modify this one, you can get the formula for the infinite line current. H is equal to I by 2 pi rho. What is this rho? Rho is a perpendicular distance. So that is also important. Let us have one question. We have seen one shortcut here. Let us have one question here. Yes, here is a question. H is equal to is the expression for the magnetic field due to an infinite linear current carrying conductor. So what is the expression here? Magnetic field due to the infinite linear current carrying conductor is H is equal to I by 2 pi rho. Here he is asking the magnetizing force, magnetic field intensity. So it is the H ampere per meter. For the ampere per meter, there won't be any mu. So its units are ampere per meter. You can observe in the options there is an ampere per meter. So in the ampere per meter, there won't be any mu. So there is a mu here, you can discard. There is a mu here, you can discard. There is a mu here, you can discard. So answer will be from these and these two things. So it is I by 2 pi r. So option B is the answer. Directly it is a formula based question. Okay guys, one more question we can have. Numerical question. A long straight wire carries a current I is equal to 10 amperes. At what distance the magnetic field is? H is equal to 1 ampere per meter. Okay. So you can use this formula. H is equal to I divided by 2 pi rho. How much he has given? 1. So he is asking at what distance? He is asking the distance. So rho is equal to I by 2 pi. How much is the current? It is 10 amperes. So 10 by 2 pi is the answer. So 10 by 2 pi can be written as 5 by pi. 10 by 2 pi, it's there. 10 by 2 pi meters. So you can observe the option here. Option B is the answer. 10 by 2 pi. 10 by 2 pi meters is the answer. Okay guys. So this is all about what is called, yes. So this is all about magnetic, what are the formula we have seen? Magnetic field due to the finite length conductor, infinite length conductor, one shortcut. Let us have one more formula. Magnetic field due to circular loop. Okay, this is also important. What is more important is this one, magnetic field at the center of the circular loop. This is very, very important. Number of times questions was seen on this. Okay, and that too with the fixed numerical. Okay, we'll come to that point. So let us try to understand this one. So there is a circular loop. Current is flowing in the circular loop. How much current? I amperes. Okay, I want to find out what is the magnetic field away from the center. At what distance? At a distance of B. So this, let us say this is having a radius A. I want to find out what is the magnetic field at a distance of B. This is a B. What is the magnetic field here away from the center? Okay. So here is a magnetic field. So you need to put your thumb in the direction of current flow. Your fingers will going to show the direction of magnetic field. So the magnetic field direction is like this. If I put my thumb in the direction of current flow, so this is the direction of magnetic field. So magnetic field is in the Z direction in the given coordinate system. Okay. So directly I will going to give the formula here. So the B vector is equal to mu into I into A square into Z cap divided by 2 into A square plus B square to the power of 3 by 2. Units are Weber per meter square. Okay guys, so what you can remember only the scalar part. So mu, just magnitude, B is equal to mu into I into A square divided by 2 into A square plus B square to the power of 3 by 2. Units are Weber per meter square. So if you want to get the H vector, what is the H vector? B is equal to mu into H. So what is the H? H is equal to I into A square divided by 2 into A square plus B square to the power of 3 by 2. Units are ampere per meter. This formula is not that much important for the exam. I will not going to highlight. So where you are finding the magnetic field? You are finding the magnetic field away from the center at a distance of b. So for your exams, what is more important is at the center. So to get the magnetic field at the center of the circular loop, you have to make b is equal to 0. So that is very, very important. So at the center, what you need to do, guys? You have to make b is equal to 0. What is the formula here? B is equal to mu into I into a square divided by 2 into a square plus b square to the power of 3 by 2, which is equal to mu into I into a square divided by 2 into a square plus 0 square to the power of 3 by 2. So b is equal to mu into I into a square to the power of into 2 into a square to the power of 3 by 2, which is equal to mu into I into a square divided by 2 into a cube. So what is this b? B is equal to mu into I divided by 2a. Units are Weber per meter square. What is the H vector? It is I by 2a. Units are ampere per meter. Okay, guys. So these are the formulas, guys. So these are very, very important formula. And do you know what is one of the most popular question? A circular loop is having the diameter of 1 meter. So and carrying the current 1 ampere. So what is the magnetic field at the center? So diameter, A is the radius, 2 into A is the diameter. So that is 1, current is 1 ampere. So 1 divided by 1 is the answer. So with the same numerical, number of times question was asked. Quite interesting. Okay, guys, let us have question here. You can see this question. Okay, if a circular conductor carries a current of I amperes having the radius r meters, then the magnetizing force at the center of the coil is given by. So just now given, so the magnetizing force H is equal to I divided by 2r, 2a. Okay, your radius is r, it is 2 into r. Units are ampere per meter. I divided by 2r. Option B is the answer. Okay, next. Yes, substitution kind of questions can be seen. So let me recapitulate here. What are the things we have seen here? So we have seen some very important formulas from the electrostatics part and magnetostatics part. From the electrostatics part, what you can do? This is what I can. From the electrostatic part, electric field due to infinite uniform line charge, electric field due to infinite uniform sheet charge. The other important thing is a Gauss law. You have to focus on the Gauss law. The extra important point is a Gauss law. Okay, and capacitance. Capacitance on some different geometries like a coaxial cable, like a spherical capacitor. Okay, some special geometries. So these are the some extra things you need to focus on the electrostatics and Coulomb's law and all those things. I am talking about important things. From the magnetostatics, what are the things I have covered in this revision session? Magnetic field due to finite length conductor, infinite length conductor, magnetic field due to circular loop. So you have to remember, you have to get one more thing here, sheet current. Magnetic field due to infinite sheet current. Important things I am writing. The other one is Ampere's law. Anyhow, you have to go through entire syllabus. Just this is a survey based on the previous papers. So on these topics there was a questions. Okay, guys. From the time varying field, Faraday's law. Anyhow, you will be learning that Faraday's law in your machines. So these are especially you have to focus much on this electrostatics and magnetostatics, Coulomb's law, electric field, point charge, line charge, surface charge, volume charge, different types of charges. Okay, and then electric field due to the infinite line charge, infinite sheet charge, Gauss law. Okay, and then capacitance. When it comes to the magnetostatics, Biot-Savart's law, different types of currents like a line current, sheet current, volume current. Okay, and then Ampere's law. fine, and magnetic field due to finite length conductor, infinite length conductor, magnetic field due to infinite sheet, which I have not discussed in this session. So, and inductance, inductance of some special configuration, something like a toroid. Yes, the very popular one is a solenoidal. So, you have to go through the inductance of the toroid as well. Okay guys, fine. So, these are the topics we have focused. I have taken the very, very important topics. Okay guys, and those are the extra topics which I have listed, you need to focus. So that there is so in the ideal case, you need to go through all the syllabus, fine. So those are the topics based on the previous paper observation. Okay guys, yes, that point need to be noticed. But in your exam, the question can be from any part of your syllabus. Okay, fine. So what should be your preparation strategy here? Obviously, you will be making some notes. You have to prepare some short notes of formulas. All the formulas for your quick reference. Okay, better you prepare the short notes in the A4 size paper, so that you can take a pic of that, and whenever if you wanted to update that one, okay, you can add one more paper easily. Okay, so write down all the formulas, revise them. Yes, the very important. So you have to revise and you need to solve the previous questions. Okay guys, so the previous questions is also very, very important. So that you will know what is the standard of questions, what is the nature of questions asked in the paper. Just understanding the concepts is not enough thing. You have to apply those concepts. You have to understand, you have to apply. Ultimately, in the exam, you must be in a position to solve the questions. That happens when you tune yourself to the previous papers. And if you want to have the feel like exam like environment, the test series is must. Okay, where you can correct yourself, you can learn from your mistakes. Okay, complete the exam like environment you will get from the test series. So from the ACE Engineering Academy, we are providing the test series for your exam. So for SSC JE 2024, mega mock test is there on 26th May 2024. Online mode it is for the civil engineering students, mechanical engineering as well as for the electrical engineering. So the timing is 1 PM to 3 PM and the fee is only 100 rupees. Okay guys, please note this one. Make a note of the day. And you can register here in the mock test. Okay, you must write more and more mock tests so that you will get some exam. You will understand what is the nature of the questions, isn't it? Learning the concept is not just enough thing. Okay, so when you write more and more number of, that is where you can learn the things. So when you solve the questions here, so when you are preparing the short notes here, you'll prepare something. And when you solve the questions, if you would not able to make a solution for that, and you will get to know that, yes, so this is where I am missing. This is a concept I need to refresh. So that is where you will go back to the notes, or even if that happens when you solve the test series also. So after solving the test series, you have to introspect. Introspection is must. So where you are doing mistakes, what are the concepts you are weak, what are the concepts you are not comfortable. So that is where you need to introspect, and you need to go back to the short notes, and you need to, if it is any data is not sufficient, if there any requirement for the updation, so you can update that. Okay, so this kind of feedback thing you have to develop, then you can master the subject for our exam specific thing. Okay, so the mastering the subject does not mean that you have to read entire subject, no. So you have to tune ourselves only to the exam what we are targeting. Okay guys, yes, so this is all for this session. I will wish you very success for your exam, what you are going to write, and even for your future endeavors. Okay guys, all the best. We'll stop here. Thank you.